Thank you for joining and welcome to the iNEMI webinar to launch our call for participation for this new iNEMI project on PCB Connector Footprint Tolerancing. As I said, my name's Steve Payne and I'm Project Manager for iNEMI, the International Electronics Manufacturing Initiative. And today I'll be joined on the webinar by Joe Fuller, a Manufacturing Engineering Technologist of Intel Corporation, and also by Chandra Krishnaswamy of Dell and Sudip Thomas of Intel, who co-lead the project with Joe. Please note that this webinar will be recorded and the recording will be available through our website. This is the agenda for today's webinar. I'll be describing the project development process, and as I'm expecting some non-members on this webinar, non-iNEMI members, I'll start by briefly introducing iNEMI, and then Joe will describe the drivers and background of the project and the proposed project scope and objectives. I'll finish off by describing the process of how to join the project, both for iNEMI members and also the process for non-members. And as this is a fast-term project, which will finish in 12 months, it'll be possible to join this one project only. At the end, there'll be an opportunity to ask questions through the chat facility, which you should see at the top of your Teams desktop. So what is iNEMI? For those not familiar, we're an industry-led consortium of leading electronic manufacturers, suppliers, associations and universities. We're not-for-profit and our organisation's funded by a membership fee. We're truly global. We've got offices in North America, Europe and Asia, and members spread across the globe, representing the entire supply chain of electronics manufacturing. Our mission is to forecast and accelerate improvements in the electronics manufacturing industry, and we achieve this through our technology roadmap and the collaborative research projects such as this one. The key benefit membership is participating in our research projects, and that can reduce cost to our members through leveraging resources of the whole consortium and reducing risk of technology introduction. We've over a 25-year heritage of successful projects which have addressed knowledge gaps in our industry, and they uniquely bring together a global supply chain. And an up-to-date list of our projects, together with a brief description, can always be found on our website. Now, within iNEMI, there's a PCB and laminate technology implementation group, which supports projects related to PCB fabrication. And I just briefly describe some of these on this slide. And currently, we've got 4 additional projects in addition to this connector project. First, there's the reliability and loss properties of copper foils for 5G applications. That started about a year ago, looking at surface finish of copper foil and also the copper alternative finishes on how roughness is measured, the effect of roughness on conductivity at high frequency and signal loss, and the reliability considering the adhesion between copper and the resin systems. Next, we have a project looking at CAF failures in multi-layer PCBs, and particularly looking at microvire structures, including blind and buried microvires. The third project, looking at the impact of material placement and CTE mismatch on hybrid PCBs, including their thermomechanical performance, all through simulation software. And the last one, you can see it's at an earlier stage. This is a new initiative looking at PCB material properties when immersed in cooling liquids. There's further project proposals with such things as flame retardancy testing of halogen-free laminates, PCB pad crating and optical PCB interconnects. If anybody's got an interest in any of those topics I've just mentioned, then don't hesitate to contact me. So let's move on to briefly look at the project development process. Input of project ideas often come from our technology roadmap. As you can see on the slide, the 0 at the top, that's where the input can come from the technology roadmap through a gap analysis, and that identifies key industry issues that are best solved through collaborative effort. Additionally, and very importantly, all iNEMI members can propose new ideas for a project. iNEMI staff such as myself, we support the project proposals, help form an initial team, and develop a project plan, which is developed in numbers 1 and 2, as you can see in the slide. Moving on, after the planning of the project, from stage 4, when the project proper starts, then the project is limited to iNEMI members or fast term project members. Before that, the project plan goes through our technical committee for project approval. A key document covering projects is the project plan, or what we call the statement of work, the SOW. And that sets out the purpose, scope and objectives of the project and outlines the project tasks and also the resources required, together with a schedule for the project. In addition, there's a project statement which is signed by all participating organisations and commits each project partner to the resources required to make a successful project. Project participation requires iNEMI membership. As iNEMI staff such as myself, we administer and coordinate the project. We arrange the regular meetings by Microsoft Teams. We record the meetings. We do the meeting minutes and coordinate the various tasks, ensuring the schedules adhered to. And we also support the project team with publishing any reports and papers and helping with any presentations. But I would like to emphasise that our projects are always industry-led, and the project chairs or leaders always come from our active membership. Now, without further ado, let me introduce Joe Fuller, who will now describe this exciting new project. Joe, over to you. If you just let me know when you'd like me to change the slides.
Okay, thanks a lot. Appreciate that, Steve. And go ahead and, yeah, that's perfect. So I'm going to go over a little bit of what is driving this project. I'm not going to go into every detail, but there's a couple of major changes that have occurred in the industry with regards to adding cards and their connectors. And we'll talk about more as we go, kind of the details of which ones we're trying to target. But the two major drivers are the fact that we have new specifications like SFF TA1002 and some other TA1000XX that have a very much reduced pitch, and that's driving some of what is new and maybe challenging, as well as additional increases in frequency. And that's what I want to talk about on this page a little bit, because these increases in frequency are also driving changes that are challenging for fabrication and design. So the chart that you see here is from PCIe SIG or PCI SIG. And what it's showing is that on the green line, if the bandwidth were to double every 3 years, this is what it would look like. And the sort of bluish purple line is where we're really at, which means that we're actually doubling faster than that. If you look at the line, there's really an inflection point around PCIe 4 to PCIe 5, where it really starts to increase at a very rapid rate. And I think that most of you, if you are in that sort of curve and you're transitioning to 4 or 5, even maybe considering what 6 might hold, I think you're very aware of these changes. And this is a really significant driver to what's going on and how the physical designs are changing. So go ahead and go to the next page, please, Steve. So let's just talk a little bit about the pitch reduction. And this is page 45 and 46. I pulled out a couple of pieces and kind of put them together here. And this is the 4C plus mating card gold finger pattern, and circled in red is the critical dimension to take away from this whole thing here. And it's the true position is 0.1. That can be translated roughly into plus or minus 0.05 millimeters. And what that is that's the tolerance to the D, G, and F datums. Now, D and G are the face of the card and the bevel edge, so that's just squaring it up. F is the center line of the keyway in the center of the pattern on the left-hand side. And that's really the critical one. And this is where it's significantly less than what we've dealt with in the past. And this is really one of the main drivers, and this is kind of where the name of this project came from, was this was kind of the first thing that everybody saw and said, wow, if they saw it, said, wow, this is going to be challenging. And when they provided to their PCB fabricators, a lot of the fabricators came back and said, yeah, this is going to be difficult to not possible in some cases. And so this is really the kind of the starting point of, hey, this is something new. It's going to be difficult. We're going to have to do some special processing, potential, looking at whether we're really going to try to hit this spec or not, and the implications of that. So let's go ahead and go to the next page, please. Okay, so here we have a page from the PCIe Express spec Rev 5 or generation 5. And this is from page 188, and it shows a really good example of how some of the changes have manifested themselves from high-speed signaling. So you can see here that we have vias that are now placed in the area where we have electrolytic nickel and gold plating. This is for most people, including myself when I first got this, this was something new, and understanding exactly what you can do with the vias in those locations is really critical. Additionally, you can see that there's a spec there that says 0.13 at the bottom edge of all of those pads. And what that's indicating is that you're not allowed a bus bar stub length or remnant length more than 0.13. And as you can see, they're not all lined up. So the method of using chamfering to cut off your bus bars is clearly not going to work in those areas. So that's going to drive a different process and implications from that process. And this is really where, and this is not, if you look closely, there's some other things in there, but really these are kind of the high points of why this is something that we need to start to pay attention to. And really, I'm not going to go into any more details about, what the risks are, but as you can see, just from what I've presented, this is something that we can't just be taking a design and throwing it at our PCB fabricators and expect everything to come out well, like we have up through PCIe Gen 3 and potentially even 4, although you probably shouldn't have on 4. Okay, next page. Okay, so what exactly is the potential here? And I think this is kind of what I alluded to on the last page. If you have a PCB designer that doesn't understand what the risks are, what the problems are, what the challenges are, you get into a situation as a PCB fabricator where you're having to educate your customer. And that's never a good thing, especially when that education comes with, hey, we might have to change processes that are going to increase your cost. We may ask you to make design changes that fit with our fabrication processes. And there may even be risks that the PCB fabricator are not aware of, but then come to fruition, and then there's an issue between their customer and them, and those are the kind of things we want to avoid. It's also true for the connector supplier, because if the PCB designer doesn't understand the risk, doesn't understand how to design it, and they design it in a way that causes problems, but they don't know that they're the ones that did that, they are very likely going to go back to the connector vendor and say, hey, we're having connection problems. You need to help us. And then you have to spend a bunch of time and effort and educating your customer, going through and root causing and doing a lot of work that really should never have occurred to begin with, right? We should have the PCB designers well educated, fully understanding the risks, fully understanding what they're getting into, so that things will go as smooth as possible and we don't have these kind of conflicts between the suppliers and the customer. So that's what we're trying to, that's the very, very high level that we're trying to alleviate. Okay, go ahead and go to the next page. So some of the things we're looking at, we went through a big list of standards and footprints, and what it comes down to really is PCI Gen 4 and 5, as well as a couple of our SFF TA 1000 specs, so 1002 and the 1020. Now you may say, well, you know, what about Gen 6? What about TA 1033? One of the things we didn't want to do was include standards that weren't complete yet. As those become released and they're complete and they're done, we will consider adding them. For right now, we didn't want to deal with anything that wasn't fully released. How we decided what would be in and what would be out was really about whether or not we had complex interactions. So something like SMT patterns were not complex. If you have a tight tolerance between an SMT pad and a hole, that's a pretty straightforward thing that we've dealt with before. It's not a complex interaction. If you look at a straddle mount, which we are including, although it's not, you know, a Goldfinger edge pattern, it has a lot of the characteristics that you see in an edge pattern, where you've got alignment from a routed or drilled feature to pads on both sides of the board. And that's a much more complex, or adds a lot of complexity that you wouldn't normally get on, like, say, an SMT part. So some of the specifications we did not include are listed at the bottom here. And these are really, like I said before, they're either not final, or they're using, or they're borrowing specifications from other specs that we do have included. Okay, Steve. So let's talk about the kind of details that we would be looking at within these specifications, because clearly we're not here to look at every single dimension and everything that's in these specifications. And we're definitely not here to look at whether or not these specifications are, there's something wrong with them, right? We're not trying to push back on the specifications and saying, hey, you guys have come up with something that's not manufacturable, or we could manufacture it easier if we did this. That's not the intent here. What the intent here is that the three of us and a few other people have been working on this as we've been going along, and the new team that, you know, many of you, hopefully some of you, will be participating in, is really to take all of our experiences, and I know that the three of us, the co-leads, have all gone through this and had you know, our own experiences of trying to figure this information out, how to navigate it, how to understand the risks, and how to deal with it when we design and then fabricate a PCB. And so what we're trying to do is put together the information that we believe that somebody who comes into this new would need. And so that's really the direction, the overall arching kind of, when we were going through all of this, we kept coming back to, okay, if this is what we're trying to do, then how does it fit? And so the things we're looking at are things like the Goldfinger size and position tolerance, like we saw on the earlier page, the key slot as well, because the Goldfinger and the key slot are really what makes everything align between the connector and the board. Bus bar remnants, and we mentioned that earlier. Goldfinger south edge position when they're different length, and how do you deal with that? V is an electrolytic nickel gold plating area. V is a narrow Goldfinger pads. The SFF-TA 1002 and 1020 spec both require V is in Goldfinger pads, and so that's another concern. And then any other impacts that we see from the specifications based on these high-speed signals. And in Gen 6, if that's released and we decide to increase it and put it into the program, into this project, or if we do a follow-on, Gen 6 has some design changes as well, even though the frequency isn't increasing. They're introducing PAM4, and PAM4 has crosstalk sensitivities that are driving some changes as well. So this is going to continue to be something that we need to stay on top of with future speed increases like we saw on the first page there. Okay, Steve. Okay, so the objectives and plan. And I'm going to repeat myself here a little bit, is we really said, okay, if you're going to lay out a PCB with PCIe Gen 5 or EDSFF specs for the first time, what do you need to know? And so really the very first thing you need to know is, why is this a risk? And a lot of that is really about the PCB fabrication. So we said, well, you know, the reason we're doing this through a consortia is so that we can collect data from a broader range than any one of us could if we just sat down and wrote a paper about our own personal experience. So the very first thing we want to do is we want to go talk to the fabricators and start to get some information and really understand how they're seeing this problem, how they're dealing with this problem, what kind of capacity they have for some of the special processing that may be needed. Those kind of things are really going to be key to understanding for somebody who picks this up. And in my experience, you know, my very first thing was, okay, I believe there's a risk. Now I got to go convince other people in my organization. And this is the kind of data that will help with that. Say, look, here's industry surveys, lots of suppliers, and this is what they say. And this will give them the basis to justify, hey, we need to spend more time and effort on this than we did on Gen 3 or Gen 4. The next part is really being able to assess the risk. Now that you understand that there are risks, how do you assess them? And the very first thing is and this is, I have an example from my own experience. I put together some information when I first started working on this, and I provided it out within my company. And somebody called me and said, hey, we're using SFF-TA 1002 with the 0.6 millimeter pitch, but we're only going to do Gen 3 speeds over it. And I thought about that for a moment. I'm like, well, okay, that does change the equation. There are some requirements that are literally just for the high-speed signals, and there's some that are just for the pitch. And so it actually removes some of the risks for that person when they were doing low-speed routing over it. So in describing the risks and when they apply is a really important part, because the way that you're designing your board, whether it be via structures or your signal speeds or some other things, other details of your design, can eliminate or add certain risks. And so that's a really important thing to be able to do. And then, you know, I'll clearly look at the supplier capability for the processes that has shown you that you probably need. And then the third thing is really providing some tools that can give you the kind of numbers that you need to evaluate against your product category. So here we have DPMU, which is defects per million units, which describes a add-in card as a single unit, because if you have one failure point along all of your gold fingers, then the whole card doesn't work. So understanding that DPMU can give you the ability to say, this is the level of risk, or this is the level of processing technology that I need, because if you work in consumer electronics, your DPMU level that you can accept is probably a lot higher than if you're working in, or you're doing products for the medical field, per se. So this is where you can customize what you want to do based on the DPMU that your industry will accept. So the last part of this is you've gone through and done the design, you've figured out what processes you need, you determine your risks. Now, how do you make sure that your fabricator is giving you what you designed and what you expected? And this is where we intend to provide, and some of this will come from the suppliers as well as the team's experiences as well, recommendations on how to document and communicate the kind of things that you want the supplier to measure. Excuse me. One of the interesting things that happened to me was we took the specification that you saw on the previous page, and we just put it into our drawing and said, you know, measure the boards. And we got back measurements for every single reference measurement, and that was on that thing. There was over 30 measurements. And the funny thing was the two that were critical, the pad position relative to or actually three, pad position relative to the key slot width, and then pad width. Those three were the only three missing out of the whole list. And so it was my introduction to, oh, you have to be a lot more specific about what you really want. And that's what we're talking about here. And then there's also recommendations for, you know, the measurement methodologies, how to measure them, what the quantities should be, and those kind of approaches. And so really it goes through the whole entire process of, hey, here's a risk, and make sure everybody's on board. Understand exactly what risk you can accept and how to evaluate it, whether you're using FMEA or some other process that your company likes to use. We will provide you, this project will provide you with the inputs you need to be able to go through that process. And then the last thing is really working with your supplier to make sure you get what you expect. And all of that will be in the final report. Like Steve mentioned earlier, we want to do this as a fast track in 1 year. We think this is really important to get this information out and in people's hands so that they can start using it. Okay, Steve.
Thanks, Joe.
Go ahead. Yeah, sorry.
Thank you. Thanks, Joe, for setting the scene on this exciting new project. And now I'm going to describe the important stuff on how to be part of this project. Now, we're going to start the project sign-up phase soon, in the next day or two. We've got 2 call for participation webinars. Obviously this one, session 1, and this later on today, this session 2, and hopefully the 2 of them will cover most of the time zones. So from that, the sign-up period will be open, and iNEMI members can sign up for it. And the sign-up period will probably be about 6 to 8 weeks or so. We have a deadline for signing up, but we appreciate the challenges of signing off on the resource commitment. So there's some latitude here, assuming we get to know, your intent to sign up, your interest, etc. I think, as mentioned, meetings are held by Microsoft Teams. And typically, we like to hold calls probably every 2 weeks or so, and they'll be scheduled in advance for the year in advance. As Joe said, the project duration will be 12 months. So, and we'll be looking to start therefore towards the end of June formally with the project. So how do we sign up? iNEMI membership is required to join the project, or you need to become a fast turnaround member. But if we think about iNEMI membership specifically, if you're already an iNEMI member, and the next slide, I'll go on to those of you that are not iNEMI members, so you just hold on. But this slide's particularly about iNEMI members. It's a very simple process for iNEMI members. You just need to download and review the two documents, the statement of work and project statement, and they'll be on the web page, the project web page. So if you go onto the iNEMI website, and I can help you with that if you need to, under projects, and you look for our project under the connector project, on it you'll see a place to click to download the statement of work, which is the project plan, and the project statement, the PS. And the project statement is the document you need to sign. Just fill in your company name and sign it. We need a signature from the person that's going to participate, or one of the key people that's going to participate, and also a signature for management approval. And then it's also got a feature for an electronic signature as well. So you can either download, print it off, sign it, or you can do an electronic signature online. Then you submit it. If you then forward and send it to myself, and then Grace O'Malley, who's the iNEMI Vice President of Technical and Project Operations, will sign and approve your participation and send you back the completed project statement with acceptance. So that is for iNEMI members. As I said, a very simple and quick process if you're already an iNEMI member. So if you're not an iNEMI member, then of course one of the first things I'd like to recommend is that you consider iNEMI membership, because there's so many more benefits than this one project. And so really, without delay, if you have interest, then do contact me or any other iNEMI staff member in your region, and our website has got the full contact details. And we can arrange a one-to-one call to describe the full benefits and value of membership and support you in that decision to join iNEMI. And if you're joining iNEMI, we realise this decision can take some time, but if we know your interest and intention to join iNEMI, and in particular this project, we can allow for your participation as the project starts. So we'll allow you in, and you'll get invites to the project starts while you're in the sign-up process. So for iNEMI members, there is an option with this fast turnaround project to get involved. Let me move on to this next slide here. If you see the second part of it, it's to join as a fast turnaround member. And you can join as a fast turnaround member for what is for most organisations a much reduced fee. If you're a very small organisation, then it can be probably just about the same cost to join a full membership as it is just the fast turnaround member. The fast turnaround membership with this reduced fee is just a one-off fee for just this project. So it doesn't limit you to just involvement in this project, whereas a full membership, you get a wide variety of benefits of all the projects, initiatives, and resources and networking, etc., that full membership gives you. So what we'd recommend is that you can again download and review the statement of work, the project plan and project statement, and then contact me for an MOU, a memorandum of understanding for fast turn members. And we can help you with all the sort of legal documents and get copies of those for you. And then if all's well, then you can sign the project statement and the MOU, return it, and then pay the invoice for this one-off fast turnaround fee. And then you get membership effective full membership, but just of this one project. So that is the two means of joining the project, and I appreciate it's perhaps a lot to take in all at once, but I do suggest that, do recommend if you've got an interest, then do by all means contact me, and we can do a one-to-one to talk you through, help you through the process. So with that, I'm going to thank you very much for calling in on the project. I'd like to thank particularly Joe and his colleagues for all their leadership, for Joe, Sudhir and Chandra for their leadership during the early stages of this project. And we're happy to receive your questions. As I mentioned, please use the chat function in this Teams calls. And you'll probably find that at the top. You should find at the top of the top bar of chat. You click on that and write your chat, and then we can answer it. And we can, you can ask questions both on the technical aspects of the project, but also any of the iNEMI questions you might have about joining or anything else about the projects as well. I can help with. So let me pause now and encourage you to just use the chat function. Hopefully you're able to use it. If you think of any questions afterwards, after you call out, then by all means you can email me, and there's my email address, as you can see on the slide. You can also find it on the website as well. So again, thank you very much for calling in, and we're happy to take your questions now. I think we've got a question coming in there, haven't we, Joe?
So Steve, I think if you unmute John, he can ask, or do you want it in written form?
Yeah, let me see if I can unmute John. Yeah, I think you're on. Yeah, that's it. Fine,
good.
thanks.
Yeah, thank you. This is an easy one. What time of day would the meeting be? As I work I'm an international engineering manager, so I have a lot of conference calls in the evenings, including iNEMI meetings. I just wonder what time this one would likely be.
Well,
would it be an evening call, or it'd be Asia time daytime, or US time daytime?
We usually, I think there's a good question there. We have a range of calls at the moment. Project calls are about this time of day, aren't they, Joe? Remind me. I think this is about the time we hold our meeting so far. What we typically do is see.
Yeah.
We typically see what the membership is like, and effectively trying to arrange a time that's convenient to most, if not all the project members. They're usually in US daytime, effectively. But if you're on the West Coast, then we try and make it slightly later in the day, the US time. If there's a significant number of people from Asia, then for some meetings I hold them, if you like, what let's call it early evening or mid-evening Eastern time. So that will be very early in the morning Asian time, but that seems to work. Occasionally we hold two meetings, alternate meetings to allow for different time zones. That's more unusual, I think. It's rare we do that, because we'd like to try and keep to one meeting if we can. But at present, the meetings that we've held so far are in this sort of time of day.
Okay, thank you. That's understood. Thank you.
Hey, Steve, I think Zing is looking for a link for SOW and PS to download. I hope you can provide the link to him.
Yes,
Zing
yes,
from,
I can. Yes, yeah, I can do. I should say actually that we will follow up with everybody that's registered, which of course all of you that are attending have, and probably there's a few more that weren't able to make it. We will follow up with you all and provide a link to the web page there. I can probably quickly show you the web page. I'm not sure the links are up yet. We've literally, you know, be sign up will be after these pair of webinars, but I can check on that.
Well, while you're bringing that up, Steve, there's another question from Glenn Moore, and the question is around required resources. And so I don't know that we have anything listed on the website, but I can talk to that a little bit. Because this is a quick turn project, really the only thing we're doing is going to be doing the survey with the PCB fabricators. So there won't be any boards being built or anything like that. Although the PS document, I believe the standard text in there does say that there would be at the minimum a $500 requirement from each of the participants. That is not planned in this project. We don't plan on having any actual expenses. It'll just be time. And Steve, correct me if I'm wrong here, but I believe that the time commitment is in the range of about 3 to 5 hours per month. Is that correct? Is it, or is my memory bad?
Yes,
okay.
I'm sorry, it's actually in the project statement document, and I think you're right. I think it's in that region, and that includes probably there'll be an hour meeting twice in the month. I said every 2 weeks, so there'll be a couple of hours, probably minimum of project meetings. I mean, not everybody attends every project meeting; it just doesn't happen, of course. But we like to have you know, attend a reasonable number. So there's a couple of hours a month that will be the project meetings, and then the rest is for any other actions that may be outside of the meetings.
Right, and there's going to be plenty of sections. You can see in there, you know, just going through the document so far. We're probably going to split off into smaller teams and take on some of those tasks in that way. So that's kind of how I'm expecting that the work will be done. That's done outside the meetings.
Yeah, I think there's another question there about the meeting minutes, meeting notes. That is down to me, actually, and it's a good question. I like to produce them within a day or two of working day or two of the actual meeting, because they carry the meeting minutes. My meeting minutes carry actions at the end of the meeting minutes, and I actually call them meeting notes, really, because I perhaps don't record every word, every verbatim, effectively every word, but the meeting notes, at the end of them, there'll be a list of actions, agreed actions, and a draft agenda for the following meeting as well in 2 weeks' time. So I do like to get them out within a day or two of the actual meeting being held. I mean, sometimes, occasionally, I must say, they might be issued the same day. That's probably rarish, but I certainly don't like them being any longer than, say, 2 days after the meeting.
And I'll say, Steve, you take excellent meeting minutes and notes and very detailed. So that's always very much appreciated.
We do. I do record the meetings just for producing the meeting minutes purposes, actually. But if everybody agrees, and it needs everybody to tend to agree, that sometimes we do keep the recording for a little while. If somebody particularly is not able to attend and they would like to benefit from the actually listening to the meeting, then that's always possible. We have it for a limited time. I don't keep the recordings. I do delete them shortly afterwards. If you, I'm showing the page now before I forget, actually. If I go back, this is, let me go start with this is the iNEMI page that you'll come off with, inemi.org. And if you go to projects, and I think they're under in progress, and then you look down under PCB and laminates, there's our 5 projects that are running, although obviously this connector one's only just, just say it's just starting. So you click on the connector footprint tolerance and you come up to the page. And of course, at the moment, it's got these webinars, the ability to register for it. Afterwards, there'll be links to this presentation, and one of the edited recordings will be on this page as well. And there is the statement of work and project statement. It's under draft at the moment. I don't know if that comes up, does it? Yes, it does actually. So we actually you can look now at the this is the project statement that you would sign to actually formally join the project. That's the page at the end you'd sign. I think very shortly, in the next hopefully few days, the draft will be taken off. And that will have an electronic, well, I won't work electronically for the moment. For that is that page, and then I go back. There is the statement of work, which is the project plan. And so you're able to look at the project plan, which provides a lot more detail of the project that Joe described earlier. There's charts like the is not table, which it tells you what the project is and what it isn't. For example, it's not to develop new standards. We're not a standards body. I won't go through it, of course, but it gives a lot more detail. And some of the schedule as well, and perhaps a little more detail on each of the tasks as well. So you're able to look at that and download it. There are also areas on our website for looking at some of the legal documents if you're not an iNEMI member. Oh, Joe, thanks. I think you put a link up there, haven't you? Thanks.
Yeah, that's directly to the project page, so you can find it easily.
Thanks.
And I noticed as you were going through there, and I pulled it up myself, the project statement actually says 4 to 6 hours a month is the expected commitment.
Yeah. Thanks, Joe. I didn't...
So I was close.
Very.
It's been a while since I looked at it. So
within tolerance, I would suggest. Okay. Any further question? Oh, I think we've got another question, have we?
Looks like Steve's got a question about the filling out the form.
Well, yes, that's a good question. He said that, yes, completing the project statement, you just need one form per company. And in fact, membership covers your whole company. And it's quite often where you have projects where there'll be several members from the same company. Sometimes they might be in different regions. There might be one in the US, one in Asia, or one in Europe. So that's quite common, and we encourage that. So yes, you just need one project statement membership form per company completed, and then everybody in that company can join.
Thank you, Steve. Thank you, Steve, and Steve Rich, for asking this question. Yeah.
So I have a question about that. Currently, it's a draft on the website. When is that going to be the final version and ready for us to use?
Hopefully in the next 2 or 3 days. I'll chase up the office later to get the draft removed from the document. I don't think it will change at all. I think it was just left there effectively. Those documents are approved on the project approval process with the technical committee. They approve those documents, but of course, up until that time, they're just indicated as draft documents, but there weren't any changes to it at that time. Any final questions? Just like our meetings are 1 hour in length, and we try and finish on the hour actually, because we appreciate all have other commitments. So we try to limit it exactly to an hour, and if it's necessary to hold additional meetings, we do schedule those. So I'll pause for a few seconds to see if there's any further questions at all. While we wait, I'd like to thank all those attendees for calling in on this project. It's much appreciated.